Hello friends, welcome back. Let us continue with the module of electrician trade. I am Rajiv. On behalf of Nimi, I will be guiding you through this exercise of dismantling and assembling power parts of various power appliances. As an electrician, you should be able to dismantle and assemble some commonly used power appliances like a cooking range, geyser, washing machine and pump. This lesson will cover all the earlier mentioned topics. On completion of this exercise, you will be able to dismantle the cooking range, geyser, washing machine and pump set, identify the faulty parts, replace faulty parts with good ones wherever necessary, assemble the dismantled electrical appliances, test them for their working. Ensure the safety by wearing proper attire, goggles, gloves and boots. The necessary tools required for this exercise are as follows: electrician toolkit, spanner set 6 to 22 mm, mega 500 volts, multimeter, test lamp 60 watts 240 volts, pulley puller 3-leg 150 mm. The equipment required are cooking range 1500 watts 240 volts, geyser 1500 watts 240 volts, washing machine ordinary 240 volts, pump set coupled with single phase motor 240 volts. Other materials required are service manual, cleaning brush, cotton waste, kerosene, grease. Let us start this exercise by repairing of a cooking range. Electric stoves are characterized by a flattened spiral coil that heats up as electric current is passed through it. There is no flame, but you can see the intensity of the electric flow by the glow of the coil. The heat directly transfers from these coils to your utensils. Electric stoves may have exposed coils or hidden ones beneath a sheet of glass ceramic that covers the surface of the cooktop. A microwave oven is also attached below the stove. Before we start testing, observe the nameplate details in the cooking range and write them in the inspection form. Disconnect the power supply and open the terminal box. The terminal box is where the various electrical components comes to the power supply. Check the screws of selector switch, indicator lamp, range timer, thermostat and tighten them. Conduct a visual examination of the elements for their good condition. Check each surface heating element by connecting to the multimeter one by one for their continuity. Set the multimeter in continuity testing mode. Place the two probes of the multimeter in the terminals of the heating element. If you hear the beep sound, then the element is okay. If you didn't, it is assumed that the element is open and it has to be replaced. Check for correct shape of each element. Next, open the panel and test the conditions of the oven racks. Test the continuity of the power cord by placing the multimeter probes between the power cord terminals and the connections to the terminal block. Similarly, measure the insulation value between all the terminals and the body of the cooking range. The insulation resistance value should not be less than 1 mega ohms. If you find any fault, replace the power cord. Reassemble the oven rack panel and other parts. Connect the power supply. Check the working condition. This concludes dismantling, checking and assembling of a cooking range. Let us start the testing of a geyser. Generally, a geyser consists of a water tank fitted with two pipes, one for the inlet of cold water and the other for the outlet of hot water. The water tank is fitted with heating elements which are controlled by a thermostat. The thermostat ensures that water is not heated above a set temperature value. The tank is normally covered with some insulating material and enclosed inside a metal casing. The principle on which the geyser works is simply the conversion of electrical energy into heat. Before we start testing, observe and note down nameplate details of the geyser in the inspection form. Disconnect power supply. Open the inspection cover of the power terminal connection and thermostat installation. First, we should have a visual inspection of power terminals, thermostat, heating element and check whether all the elements are in good condition. Check the proper tightness of the screw at the thermostat, pilot lamp and heating element. Now, Check the good condition of the heating element by measuring its resistance with the multimeter. Set the multimeter to the resistance setting and connect its leads to the terminals of the heating element. If the meter reads resistance values within 100 ohms, then the element has continuity and it is okay. If the meter doesn't read any values, then it is said that the heating element is defective and it has to be replaced. Next, conduct a visual examination of the power cord. Conduct a continuity test between the power cord pin terminals and the terminals of the geyser with the help of a multimeter. If found faulty, then replace the power cord. Conduct insulation tests between the lead and earth and record them in the inspection sheet. Measure the insulation resistance between the heating element and the body of the geyser and record them in the inspection sheet. If you find any faults, rectify them and make sure that the insulation is in good condition. Reassemble the elements. Connect the geyser to the supply and switch on. Keep the bottom cover of the power connections open. Remember, the geyser should be switched on only with water in. Check and confirm that the power is reaching all components. Confirm the working of geyser and reinstall the cover. Next, let us start the testing of a washing machine. Washing machines work by agitating the fabric with water and detergent, which helps to remove dirt and stains. The agitation process is achieved by a combination of spinning drum and an agitator, a paddle or fin-like structure. The tub is filled with clothes, water and detergent. Before we start testing, observe and note down nameplate details of the washing machine in the inspection form. Open the terminal connection panel and check proper tightness of the screws and wirings. Rewire if you find any loose or open ones. Next, conduct a visual examination of the power cord. Conduct a continuity test between the power cord pin terminals and the terminals of the motor with the help of a multimeter. Remove the washing machine drum from washing machine. Check the tightness of the shaft pulley or drum belt. Check the drum and put it back. Check the inlet pipe and outlet pipe for their good condition. Check the outgoing valve for its working condition. Check the rubber bushings that are used in the machine for absorbing mechanical vibration. Conduct an insulation test to the motor by using a megger. Place the megger terminals between each motor terminals and the motor body and check the insulation resistance values. Insulation resistance values should not be less than 1 mega ohms. If you find any faults, rectify them. After rectifying, check the working of the motor. If everything is okay, reassemble the drum and close the cover. Connect the power supply and check the working condition. This concludes the dismantling and assembly of the washing machine. Now, let us look at a pump. As the pump parts move, the air is pushed out of the way. The movement of air creates a partial vacuum which can be filled up by more air, or in this case, water. Note the nameplate details of the pump set and record them in an inspection form. Disconnect the power supply from the pump set. Check the shaft, carbon seal, motor adapter, drive collar, impeller, casing gasket and bearings for their good condition. If the condition is not okay, then replace them. If everything is okay, reassemble the pump set. Connect to the power supply and check the working condition. This concludes dismantling and assembly of a pump set. This concludes the exercise on dismantling and assembling power parts of various power appliances like cooking range, geyser, washing machine and pump set. I hope in this exercise we learn to dismantle the cooking range, geyser, washing machine and pump set. Identify the faulty parts, replace faulty parts with good ones wherever necessary, reassemble the dismantled electrical appliances, test them for their working. Thank you all. See you in the next exercise.